Okay, so Nernst equation, it deals with calculating EMF of the cell, and we see the effect of mainly concentration and to some extent temperature on the EMF of the cell. So we will start with delta G is equal to delta G naught plus RT natural log of Q, and you know what is Q? Q is reaction quotient, and at equilibrium delta G is 0. So delta G naught may or may not be equal to 0 even at equilibrium, but it is constant for the given reaction. So delta G naught is equal to minus RT natural log of, if it is at equilibrium, we can take Q as a K. So we can take it as K. At equilibrium, Q is equal to K equilibrium. So delta G naught, this is the first expression, that is minus RT natural log of K, or delta G naught is equal to minus 2.303 RT log of K. And for a cell, delta G naught is minus NF E naught cell, delta G is equal to minus NF E cell. So just put delta G equal to minus NF E cell and delta G naught minus NF E naught cell. So we get this expression, that is E cell is equal to E naught cell minus RT upon NF natural log of Q, or E cell is equal to E naught cell minus 2.303 minus 2.303 RT upon NF log of Q. And what is N here? Number of electrons gained or lost, or number of electrons transferred during the reaction. So at 298 Kelvin, E cell equal to E naught cell, and we put the value of R and T. R, it is 8.314 joule per Kelvin per mole. So E cell is equal to E naught cell minus 0.0591 upon N log of Q, and you may take 0.059 as 0.06 to make the calculation simple. You can take it 0.06. At a chemical equilibrium, delta G is 0, so that means E cell is 0. Now at chemical equilibrium, cell is completely discharged, or it will stop its functioning and it will not generate any energy. So in that case, E cell is 0. So relation between E naught cell and equilibrium constant, so it is log K equilibrium equal to N E naught cell divided by 0.0591. So this is one of the important equation. This one is also important relation. These two relations are important here. So Nernst equation for an actual reaction, if it is redox, it is a reduction reaction. So in this case, E reduction is equal to E naught reduction minus 0.0591 upon N, all at 25 degrees Celsius, log of product over reactant. So concentration of pure solid or pure liquid, any pure liquid is taken as 1. Why we take this 1 for pure solid and pure liquid? Tell me.
Sir, because when we are dealing with chemical reactions, we want something to be constant here. So concentration does not change with time, so we take it as 1.
Yes, because for pure solid or pure liquid, density is same. For pure solid and pure liquid, they have same density at constant temperature. That's why if we keep the temperature constant, density is same, and so is the concentration, that remains same, because decrease in mass is equivalent to decrease in volume. So above all, concentration remains same for pure solid and pure liquid. Now next is, question is, will the reduction potential of zinc electrode decrease or increase with concentration? If Zn2 plus is 0.1 molar in compression of zinc, in comparison to zinc, sorry. With standard, what happened if Zn2 plus is 0.1 molar? So when concentration of Zn2 plus is 0.1, it becomes log 10, that is 1. So it becomes less than E naught, means reduction potential of the cell is less than its standard reduction potential. That means as concentration of zinc 2 plus increases, reduction potential increases. See, we can write it like this. Is it true? That means reduction potential of any electrode is proportional to concentration of cations and is inversely proportional to concentration of anion. This is also important. As concentration of cation increases, reduction potential increases, and as concentration of anion increases, reduction potential decreases. Now concentration cells. So concentration cells are of two types. First is electrolyte concentration cell, other is electrode concentration cell. So cell in which both the electrodes are of same nature, but concentration of ions are different. So that is called electrolyte concentration cell. See, in this case both are zinc electrodes on both sides, but concentration of zinc is different. So question may be asked that what is the relation between C1 and C2 if reaction is feasible. So see, one method is given that you will write anode reaction, cathode reaction, then zinc 2 plus cathode is in equilibrium with zinc 2 positive anode. So if we write E cell equal to E naught cell minus 0.0591 upon 2 log of Zn2 plus anode divided by Zn2 plus cathode, or we can say, because for a concentration cell, because both the cells are of same nature, so their E naught cell is always 0. So it is minus 0.0591 upon 2 log of C1 by C2. So for a spontaneous reaction, E cell should be greater than 0. That's why C1 should be less than C2. So whenever C1 is less than C2, then that reaction can take place. So while looking at the reaction, how do you know the feasibility? This is the reaction. This is the concentration C1 and this one is C2. So tell me, how do you figure out that this reaction has E cell greater than 0, or we can say reaction is spontaneous, or reaction to be spontaneous? How do we figure out the relation between C1 and C2? Yes, beta. Answer we already know.
Yes, sir. We use the E cell equation that E naught of the cell is greater than
I wanted to explain without writing the equation, because if you write the equation, that is a wastage of time. You don't want to write the equation actually. Without writing the equation, how do you figure out? This is another another concentration cell. Pressure of electrode are different. This is called electrode concentration cell. This is electrode concentration cell, and first one is electrolyte concentration cell. In first case, concentration of electrolytes are different. In the second case, concentration of the electrodes are different. So see, how do we do it? See, in the first case, on the anode side, there is a formation of zinc 2 plus ions. On the other side, there is a consumption of zinc 2 plus ion. So when zinc 2 plus ions are consumed, when they are in excess, and production takes place when they are lesser in amount. Got it? Zinc 2 plus ions are formed when they are less. That's why zinc solid converted into zinc 2 plus. Same osmotic pressure, solution pressure that you can apply to increase the, because here solution pressure is increasing. So zinc solid is converted to zinc 2 plus if zinc 2 plus ions are a lesser amount. Just see, sorry. Zinc solid in equilibrium with zinc 2 plus aqueous and 2 electron. So zinc 2 plus ion reaction moves forward if zinc 2 plus ions are less than they are formed. If they are in excess, they move backward. So reduction takes place when zinc 2 plus ions in excess. Oxidation takes place when zinc 2 plus ions are in less amount. Therefore, C1 should be less than C2 for a spontaneous reaction. So tell me, what is the relation between P1 and P2?
Sir, P1 must be greater than P2.
See, here H2 should be converted into H plus, right? That means P1 should be greater and H plus is converted into H2. That means P2 is less. That's why P1 is greater than P2. So in this way you can figure out without writing the equation. Now I can write equation, because simple strategy is to write the equation. First is this one, another reaction is like this. So overall reaction is zinc 2 plus C2 to give zinc 2 plus C1. So what is E cell? Minus 0.0591 upon n log of product over reactant, or you can write it as 0.0591 upon 2 log of C2 by C1. So E cell is greater than 0 if C2 is greater than C1. So C2 is greater than C1 or C1 is less than C2. So without writing, you can figure out the one which is formed, that should be in less amount, and one that is consumed, that should be in excess. Same you can see next, PT H2 P1, sorry, just to write equation H2 P1 to give 2H plus 2 electron, 2H plus aqueous plus H2 P2. So it is H2 P1 to give H2 P2. So here E naught cell is, sorry, E cell is, just write 0.0591 upon n. What is n? 2 log of reactant over product. You can write simply skipping the minus sign, because it is minus 0.0591 upon 2 log of product over reactant. So I will write plus 0.0591 upon 2 log of reactant upon product. So in this case, again P1 should be greater than P2 to have E cell greater than 0 or for a spontaneous reaction. Okay, next. So in case of concentration cells, for a spontaneous cell reaction, concentration of the anodic compartment should be less than cathodic compartment, because if concentration of the ion at the anodic compartment is less, then that will form more ions, and if concentration of ions on the cathodic compartment is more, that will be consumed, and greater the standard reduction potential, so that you know greater will be the oxidizing power. Okay, so let's move forward. In which solution the oxidizing power of KMnO4 will be greater? So see, whenever we have KMnO4 in acidic medium, you know MnO4 negative in acidic medium is converted into Mn2 plus. And what about basic medium? Tell me. In basic medium, MnO4 negative is converted into very good, MnO2, right? So here there is a difference of only 3 electrons, but in this case it is from +7 to +2, so there is a difference of 5 electrons. So N is 5, so E reduction potential equal to E naught standard reduction potential minus 0.0591 upon 5 log of product Mn2 plus divided by reactant MnO4 negative raised to power 1, H plus raised to power 8. So in both cases it is written concentration of the species are equal. So species are MnO4 negative and Mn2 plus. So both the species have same concentration, that is cancelled out. So we left with 1 upon H plus raised to power 8. So H plus concentration here it is 0.01 molar H2SO4. So means H plus concentration is 0.02. In the second case H plus concentration is 0.002. So see, in the first case it is 1 upon 0.02 raised to power 8. In the second case it is 0.002 raised to power 8. So obviously reduction potential of first is greater than reduction potential of the second. Got it?
Yes.
So in this way you came to know that as concentration of the acid increases, reduction potential increases. If H plus ions are in excess, so oxidizing power of KMnO4 is more, because greater the reduction potential, stronger is the oxidizing agent. So oxidizing power of KMnO4 in 0.01 molar is greater than in 0.001 molar. Next question is calculate reduction potential of copper at pH 14. So you know, when pH is 14, what is pOH? Because it is at 298 Kelvin. So at 298 Kelvin, pH plus pOH is 14. So when pH is 14, pOH is 0. And what is pOH? Minus log of OH negative ion, that is equal to 0. So that means log of OH negative ion equal to 0, and log of 1 is 0, you know. Sorry. So OH negative concentration is 1 molar. So when pH is 14, OH negative concentration is 1. Now KSP of CuOH twice, it is mixed of equilibrium as well, okay. So CuOH twice solid gives Cu2 plus aqueous and 2 OH negative aqueous, and what is KSP? Product of the concentration of the ions raised to power their stoichiometric coefficients. So copper 2 plus raised to power 1 into OH negative raised to power 2. So KSP is given to you. OH negative ion concentration we can calculate from pH, and therefore copper 2 plus concentration we have now. So to calculate reduction potential, we need E0 value, that is given. We need concentration of copper 2 plus ion, that we have calculated. So we can calculate E reduction potential equal to E0 reduction potential minus 0.059 by 2 log of 1 upon, because it is solid, 1 upon copper 2 plus concentration. So it is 0.34, and by getting it we have value minus 0.2205 volt. Next question is, if for a concentration cell X to Xn plus with 1 upon 20 molar concentration, Xn positive 1 by 2 molar X, E cell is given to you at 298 Kelvin. So calculate the value of N. What is N? So you know, while writing the equation, see, there is no need to write these two things. You know, this part is on the right side, this part is on the left side. That means while writing the equation, we write it like this. So Xn 1 by 2 molar gives Xn plus 1 by 20 molar. N, you know, it is should be, because Xn plus is converted into X is converted into Xn plus, so there is a transfer of n electrons. So number of electrons n. So E cell equal to E0 cell, which is 0, because it is a concentration cell, minus 0.059 upon n log of concentration of the ion at anode divided by concentration of ion at a cathode. You know, this is the concentration at a anode and this is the concentration at a cathode. So it is 1 by 20 upon 1 by 2, 1 by 10. So value comes out to be 2. If you have any doubt, please do ask in between, okay? Are you getting along with it?
Yes.
Okay. So if H2 electrode is acting as anode, see, so H2 gas gives 2H plus aqueous plus 2 electron. And if it acts as cathode, then 2H plus ion gain 2 electron to give H2 gas. Here, if H2 acts as anode, H2 gas, so when this hydrogen is gas, so we take its pressure into account, and H plus ions concentration. So oxidation potential of this hydrogen electrode is equal to E naught, means standard oxidation potential, minus 0.059 upon 2 log of product over reactant. Product is H plus ion concentration raised to power 2 and H2 gas that we take into account its pressure. So concentration of gases are written in terms of their partial pressures. So see, E oxidation potential is E naught minus 0.059 upon 2 log of C square upon P. Generally, pressure of hydrogen is given. If it is not given, we take it as standard 1. But if it is given, like it is given 0.5 atmosphere, then just write 0.5 atmosphere here. And that is activity of any ion. We can write concentration divided by 1 molar. Activity of any gas, we take pressure of the gas over 1 atmosphere. Okay. So this is the question, that a hydrogen electrode is immersed in a solution whose pH is 0. Now, as pH is 0, that means minus log of H plus ion concentration is 0. That means H plus concentration is 1. Then by how much will be reduction potential change if an equivalent amount of sodium hydroxide is added to this solution? So when we add equivalent amount of sodium hydroxide, what will happen? Tell me. In HCl, we add equivalent amount of NaOH. Then what we get? H2O and NaCl. And now what is the pH of the solution? Yes, beta. It is 7 because solution become neutral. Am I right?
Yes, sir.
Okay. So that means first we take pH as 0. So when pH is 0, H plus concentration is 1, and when pH is 7, H plus concentration is 10 raised to power minus 7. Keep in mind, H plus concentration is 10 raised to power minus pH. So reduction potential is equal to, because it is hydrogen electrode, so standard reduction potential is 0. It is minus 0.0591 upon N. N is 2 log of pressure of the gas. As see, pressure of the gas is given, hydrogen gas 1 atmosphere divided by H plus concentration, and that is 1. So we get reduction potential minus 0.0591 upon 2 log of 1 upon 1 square. Log 1 is 0. So it comes out to be 0 only. And if we add equivalent amount of NaOH, pH becomes 7. So now H plus concentration is 10 raised to power minus 7. So in this way we have this 10 is power 7 and log of 10 raised to power 7, it is 2 into log 10 is power 7, so it is 14 log 10, and 14 log 10 means 14 only. So we take 14 and this way we get the value. So that means change is 0.4137. Next is calculate E cell of this particular cell and prove that E cell equal to minus 0.059 upon 2 log of C1 Ka1 C2 Ka2. Ka1 is for HCOH and Ka2 it is for HCOOH. So see, in first case HCOH gives HCO negative plus H plus. Initially concentration is C1, it is 0 0, and at equilibrium if alpha is the degree of dissociation, then it is C1 1 minus alpha 1, it is C1 alpha 1, C1 alpha 1. So what is Ka1? Ka1 is equal to HCO negative concentration, H plus ion concentration divided by HCOOH concentration. And these are organic acids, weak acids, so alpha is very less than 1. So 1 minus alpha 1 or 1 minus alpha 2, both are taken as 1. So in this way H plus concentration, it is Ka1 equal to C1 alpha 1 into C1 alpha 1. So C1 alpha 1 square upon C1 only, because 1 minus alpha 1 is taken as 1 only because they are weak acids. So in this way C1 alpha 1, that is H plus ion concentration, that is equal to Ka1 into C1 square root of Ka1 C1. So that's why it is written C1 Ka1 for H plus anode, C2 Ka2 for cathode. See, this is anodic compartment, this is cathodic compartment. So anode, hydrogen gas gives 2H plus anode plus 2 electron. On cathode it is 2H plus cathode plus 2 electron give hydrogen gas. Now on both sides hydrogen gas is 1 atmosphere. So it is electrode concentration cell. It is electrode concentration cell. So E cell is equal to minus 0.059 upon 2 log of H plus ion anode into see, this is the overall equation. H2 anode, H2 gas anode plus 2H plus ion cathode, 2H plus ion anode, H2 cathode. But there is no need to write this, don't be confused, because pressure of the hydrogen is same on both sides. So you should just write H plus ion anode raised to power 2, H plus ion cathode raised to power 2. No need to write these equations because pressures are equal. So H plus ion concentration, see, this H plus ion square becomes Ka1 C1. So it is C1 Ka1 divided by C2 K2 minus 0.059.2. So in this way we can prove it. Okay, calculate E cell for, again hydrogen pressure is same. Now we have KOH on one side and HCl on the other side. So in the anodic compartment, KOH gives K plus and OH negative ions. See, we start with 1 molar normal because it is 1 normal. So initially it is 0, 0. Now at equilibrium, alpha is given 75%. That means alpha is 0.75. So it is 1 minus 0.75, 0.75, 0.75. So H plus ion concentration is 10 raised power minus 14 upon 0.75. Why is it so? Because you know H plus ion concentration into OH negative ion concentration is 10 raised power minus 14. OH negative concentration is given to you, so H plus ion concentration is 10 raised power minus 14 divided by OH negative ion concentration. For cathodic compartment, we have HCl that give H plus and Cl negative, and its alpha is given as 90%. So now again we start, it is 1 n by 10. So 10 raised power minus 1, 0, 0 initially. So now it is 10 raised power minus 1 and 1 minus 0.9. See C1 minus alpha. So it is C alpha, C alpha. So H plus ion concentration at cathode, that is 0.9 by 10, because here we are getting H plus ion directly. So it is 10 raised power minus 1 into 0.9. So it is 0.9 upon 10. So we have H plus ion anode, H plus ion cathode, both we have. So now E cell is equal to so E cell equal to 0 minus 0.059 upon 2 log of H plus anode divided by H plus cathode. And H plus, because see this side it is related to OH negative ion, okay, but we convert this OH negative into H plus to make the things symmetrical. So H plus anode divided by H plus cathode, because both are hydrogen electrodes. So there is equilibrium between H plus and H2. So this is the case, and by solving we get the final E cell. Now this is complexometric titration type, that whenever we have equilibrium constant of the reaction, like zinc 2 plus 4 NH3 to give Zn NH3 4 plus, equilibrium constant is given as 10 raised power 9, and value of E naught or this reaction is given. So then what is the value of E naught Zn to Zn2 plus? So now there are 3 reactions we have. First is Zn2 plus 4NH3 to give Zn NH3 4 plus, its equilibrium constant is given to us. Second is Zn NH3 plus 2 electron to give Zn and 4NH3, its E naught value is given, and we have to calculate this one, Zn2 plus 2 electron. So now we make use of second and third equation. So by making use of these 2 equations, we can figure out the equation number 1. How? Equation 1 can be obtained from 2 and 3. Just we have, see, Zn2 plus on the left side. Here it is on the right side. So equation third with the minus sign. We have Zn NH3 4 2 plus on the in the second equation on the left side, but we need it on the right side in the equation 1. So again minus sign. So delta G naught 1, let us say it is delta G naught 1, delta G naught 2 and delta G naught 3. So delta G naught 1 is equal to minus delta G naught 2 minus delta G naught 3. So in this way we get the value. I hope you can do these calculations, because n, what is the value of n here? 2. Okay. So this is a question from exam, but what is the name of the exam? Your, I think NEST or from IIT. I have taken from those exams. Biological standard E naught is defined as the potential measured at pH 7. The species nicotinamide adenine dinucleotide and its oxidized form NAD positive play an important role in respiratory process. Given standard potential E naught value is given to you for NAD plus, for this reaction NAD plus plus H plus plus 2 electron to give NADH. The E naught value for the conversion of NAD plus to NADH in 1.0 molar NAD plus at room temperature you have to calculate. Yes, how do we calculate? Yes, beta.
Sir, we know the H plus concentration will be 10 to the power minus 7.
Very good. It is 10 raised to power minus 7.
And now E naught is equals to E naught cell minus 0.0559 upon 2, which is N, into log of NADH concentration upon NAD plus concentration into H plus power.
Okay, so what is the resulting value?
Sir, I haven't solved it yet. Can you give me a minute?
Yes, yes. All of you, please solve it. NAD plus to NADH is equal to E naught I will take it as 0.06. Yes, that's the glitch. Just see, if concentration of any ion is not given, any solution is not given, then you should take it as 1.
Okay.
Standard. So value is almost equal to,
Yes, sir.
okay, sorry. So keep in mind, whenever concentration of any species is not given to you, just take the concentration of that species as standard. Okay. Okay, now types of electrodes. So there are metal soluble solid electrodes, gas electrodes, metal insoluble salt electrodes. But there is no question as such on this topic, because it is not a part of NCERT as well. So at least we will brush up these concepts. Like, see, if we have, because in practicals we have this silver electrode, so Ag solid gives Ag plus electron if it is acting as anode. Now if we have solution, have Cl negative ions, so you know Ag plus combined with Cl negative ion to give AgCl solid, and overall reaction is this: Ag solid plus Cl negative to give AgCl solid plus electron. This is the overall cell reaction if it act as anode, and if it act as cathode, then reaction is reversed. That is, AgCl solid gain 1 electron to give Ag solid and Cl negative aqueous. Keep in mind these two relations. And how do we write them? So first there is a salt bridge. On the both side we will write first aqueous solutions, and metal should be in the end. See, this is salt bridge, adjacent to it we write aqueous solutions, and on the ends we write metal, and in between these two we will write insoluble salt, metal insoluble salt, that should be in the middle. So to write it is, see, E naught of Ag solid, AgCl solid, Cl negative aqueous. Here E naught of Cl negative, AgCl, Ag solid. And relation between E naught cell and Ksp of AgCl. So keep in mind, overall cell reaction is Ag plus Cl negative to give AgCl solid. So Ag plus ion, that is at cathode C, and Cl negative ion, they are at anode. So overall cell reaction, when we sum up these two, you know, we get Ag plus Cl negative to give AgCl solid. But keep in mind, Ag plus is at cathode and Cl negative ion at a anode. So at equilibrium, Ag plus ion concentration at cathode as well as at anode, that should be equal. And so, and you know, at equilibrium E cell is also 0. So E naught cell, E cell equal to E naught cell minus 0.059 upon n AgCl solid divided by Ag plus concentration at cathode, Cl negative ion concentration at a anode, and n is 1 here. Now for AgCl solid, you know, this AgCl solid, that is always at a, AgCl solid is formed at anode only. So to write AgCl solid, we will write it as Ag plus anode, Cl negative also at a anode, both are at anode. So in this case we get Ksp. And what is Ksp? Because AgCl is in equilibrium with Ag plus and Cl negative at anode. So Ksp is Ag plus anode, Cl negative anode. In this way, concentration of Cl negative at anode in terms of Ksp of AgCl and Ag plus anode, that is we have calculated. So we will write E naught cell minus 0.0591 upon 1 log of Ag plus anode divided by Ag plus cathode into Ksp. Now as the reaction is at equilibrium, Ag plus concentration at anode and cathode should be equal, and therefore we left with 0.0591 upon n. We take E naught cell on the left side, so sign is minus minus, so cancel, is log of 1 upon Ksp. So E naught cell is equal to 0.0591 upon n, that is 1 log of Ksp, and E naught cell is E naught cathode minus E naught anode, and cathode is Eg plus 2Ag and anode is Cl negative AgCl Ag. So in this way the value comes out to be E naught of Cl negative AgCl Ag is equal to, you know, E naught of Ag plus Ag is most of the time is given to us. So it is equal to E naught Ag plus 0.0591 upon n log of Ksp. Other example is this. So in this case, to calculate E naught of SO4 2 negative PbSO4 Pb, that is equal to E naught of Pb2 plus Pb plus 0.0591, but here instead of 1 we have now 2 log of Ksp. If both the electrodes are metal soluble salt electrodes, then you know silver nitrate on both sides, or if one electrode is metal soluble salt and another is metal insoluble salt. See this one, first one, Ag solid plus Cl negative to give AgCl solid. So it is metal insoluble salt. Ag plus 2Ag metal soluble salt. Here E naught cell is not equal to 0, and E naught cell comes out to be, E naught Ag plus Ag minus E naught Cl negative AgCl Ag, and that is equal to minus 0.0591 log of Ksp. This we have already done. Ag plus at cathode, Cl negative at anode. E naught cell and E naught that we have calculated earlier. Okay, this is the question. Calculate Ksp of AgI with the help of the following cell. Cells is given. See, first one is Ag, AgI and Ki, means I negative we can write. This is anode. Another one is Ag plus Ag, that is cathode. So see, at cathode Ag to Ag plus anode and cathode Ag plus cathode plus electron to give Ag. So overall cell reaction is Ag plus cathode to give Ag plus anode. So E cell is E naught cell minus 0.0591 upon n log of product over reactant. E cell is given to us. E naught cell is 0 because it is, if it is taken as concentration cell. If we take E naught cell 0, we took this E naught cell 0 or not equal to 0. In both cases results are same. There is no difference. So E cell is minus 0.0591 upon n log of Ag plus anode divided by Ag plus cathode. And what is Ag plus at cathode? That is 0.05. So in this way we get Ag plus ion concentration, and you know what is Ksp? Ag plus anode into I negative anode. I negative anode is given. Now in the other case, if E naught cell is not equal to 0, we follow the same steps and at the end we get the same result. E naught cell minus 0.059 upon 1 log of Ag plus anode into I negative anode, because Ksp is Ag plus anode into I negative anode. See, in the second case we will write again in the same way. See, A cell, E naught cell minus 0.059 upon 1 log of Ag plus anode divided by Ag plus cathode. Here reaction, you know, it is Ag plus I negative to give AgI solid. So write the equation for it. So it is E cell equal to E naught cell minus 0.059 upon 1 log of 1 upon Ag plus cathode into Ag plus anode. So overall E cell is minus 0.059 upon 1 log of Ksp minus 0.0591 upon 1 log of 1 upon Ag plus cathode into Ag I negative anode. So overall E cell comes out to be Ag plus anode I negative anode, that is Ksp, Ag plus cathode into I negative anode, that is from this equation. So Ag plus anode divided by Ag plus cathode, because this part cancelled out, and we have this E cell equal to, and the same equation is on the other side, that is Ag E cell equal to E naught cell minus 0.059 upon 1 log of Ag plus anode Ag plus cathode, because instead of E naught cell we write this part. Instead of putting it 0, we will put it at minus 0.059 upon 1 log of Ksp, and therefore finally we get the same equation. In this case, just keep in mind this one, this formula dE by dt, that is temperature coefficient. Question may be on this topic because it is E2 minus E1 divided by T2 minus T1. If there is variation of EMF of the cell with respect to temperature, then the ratio of change in EMF of the cell to the change in temperature is called temperature coefficient. Okay. Now electrolysis and electrolytic cells. So whenever there is electrolysis, you know, reaction is taking place in the cell is spontaneous or non-spontaneous?
Non-spontaneous.
Yes, whenever we have an electrolysis or electrolytic cell, then you know it is behaving opposite to the electrochemical cell. So whenever we recharge the electrochemical cell that behaves like electrolytic cell, because battery will help to do the reaction. Yes. So during electrolysis, these ions are deposited in the order. Whenever H plus ion is in contact with copper, silver or gold, they will gain electron with respect to H plus. But if these aqueous solution of iron 2 plus, zinc 2 plus, aluminium, magnesium, sodium, calcium or potassium is there, then H plus ion will gain electron and we get hydrogen gas. But H plus ions are in very little amount, so overall we will write it as H2O liquid plus electron to give H2 gas plus 2OH negative. In this way we will write this reaction. Why is it so? Because in aqueous solution H plus concentration is very less. Same for anions. This is the order of deposition: sulfate, nitrate, hydroxide, chloride, bromide, iodide. So iodide will lose electron as compared to bromide, then chloride, hydroxide. Means sulfate has the least tendency to get oxidized, sulfate and nitrate. So electrolysis of molten PbBr2. So when we have molten anode, Br negative ion give Br2 gas. At cathode, Pb2 plus gives Pb solid. If we have molten NaCl, there is no competition because there are only two ions. One is Na plus, other is Cl negative. So tell me, if we have dilute H2SO4, using platinum electrode. So tell me, what are the products formed? Yes, beta. Electrolysis of H2SO4, dilute H2SO4. What are the products formed? What are the products formed? So in this case we have, yes, tell me.
Hydrogen gas and oxygen gas.
Yes, because there are, see, at cathode there is no competition at all, only H plus ions are there, so that will give hydrogen gas. But at anode there is a competition between sulfate and hydroxide. So deposition of hydroxide ion hydrogen ion will give O2 plus 2 H2O plus 4 electron. And what if we have concentrated H2SO4? Electrolysis of concentrated H2SO4, tell me. Then what are the products formed? Hello?
Hydrogen gas will be.
Okay, hydrogen gas and another one?
Can we say that because of the sheer number of sulfate ions, can we say that sulfur will also be positive?
Very good. Because now we have H plus, OH negative and sulfate ion, right? So at cathode there is no competition at all, only 2 H plus ion will give hydrogen gas, but at anode again there are OH negative and sulfate, but now concentration of sulfate is higher. So you know, if concentration of anion increases, reduction potential, it will increase or decrease?
Decrease.
Yes, reduction potential decreases. That's why sulfate loses electron. What is the name of this ion? S2O8. H2S2O8. Yes, it is, yes, peroxo disulfuric acid. And what is the oxidation state of sulfur here?
+6.
Very good. Is there any peroxide
Yes.
group?
Peroxide.
So there is a peroxide group. And what is the other name given to it?
Is it oleum, sir?
No, no, that is,
Oh, that's H2O7, right? H2SO7.
yes, that is oleum. H2SO4 plus SO3. That is called oleum. And its another name is Marshall's acid. Okay, now if we have silver nitrate using silver electrode, what are the products formed at cathode and anode? And what is the electrolysis of silver nitrate using silver nitrate, using silver electrode? So what is the effect on the concentration of silver nitrate? Yes, beta.
There is silver or active electrode?
Yes, silver is active electrode. Very good.
So it will oxidize and reduce silver.
Yes, and what is the effect on the concentration of silver nitrate? So concentration of silver nitrate remains? Yes, remains same. Very good. See, at cathode there is a competition between Ag plus and H plus. So obviously Ag plus will gain electron. Just keep in mind that if there is silver, copper or gold, only then they will gain electron in comparison to H plus. At anode there is nitrate and hydroxide, but at the same time, you know, silver is attackable electrode. So whenever there is attackable electrode, that will always lose electron. So at anode, at cathode, silver gets deposited, at anode silver gets dissolved. Only difference is mass of the cathode goes on increasing, mass of anode goes on decreasing, and concentration of silver ion in the solution remains same, because it is just purification of silver. We can say we will take just like purification of copper you have done in class 10th. Like this, silver start losing its anode start losing its weight, cathode start, this weight is increasing, and there is, means this is taken as impure silver, anode is taken as impure silver, cathode is taken as pure silver, and that's it. Okay, what about Faraday's laws? What is first law?
Mass deposited and gas liberated is directly proportional to amount of gas.
Yes, it is Z into I into T, or we can say weight deposited is proportional to Q, that is Z into Q, and Z is electrochemical equivalent, and that is equal to equivalent weight upon 96,500 into I into T. That is Faraday's first law, that current you should measure in ampere, time in second, and equivalent weight is molecular weight divided by N, number of electrons gained or lost. For example, if we have copper, then what is its equivalent weight? Molecular weight of copper divided by 2. Okay. And what about Faraday's second law? If cells are connected in series, then ratio of the weights deposited is equal to ratio of their equivalent weights. Okay, that we have covered. Yes, if we have to calculate current efficiency, sometimes there may be a question related to current efficiency. So current efficiency is actual mass deposited or produced divided by theoretically what is the mass deposited or produced, because actual mass is given to you and theoretically you have to calculate by using Faraday's first law, and in this way you can calculate the current efficiency. And if we have simultaneous deposition of copper and iron at any electrode, then keep in mind E cell of both should be equal. See, this is E of copper 2 plus copper, that should be equal to E of Fe2 plus Fe. Then there is simultaneous deposition of two metals. So see, E naught copper 2 plus copper minus 0.0591 upon 2 log of 1 upon copper 2 plus equal to E naught Fe2 plus Fe minus 0.0591 upon 2 log of 1 upon Fe2 plus. This is the condition for the simultaneous deposition of two metals on the cathode. Fuel cell, you know, there is continuous supply of fuel during the operation and it is a continuous cell. It is better than other cells because the side product formed is only water, which is used for drinking purpose by astronauts. Like we have hydrogen oxygen fuel cell. I think cell part, you know that dry cell, mercury cell, lead storage battery. Is there need to cover those reactions?
No, sir.
Just try them, because this, but just keep in mind these two. These are the means current efficiency, I hope you know, but this one part, condition for simultaneous, if there is a question related to that two metals are simultaneously deposited at any electrode, so keep in mind their electrode potentials, reduction potential should be equal. Yes, conductive electrolytic conductance. So whenever we are dealing with conductance or conductivity, molar conductivity, equivalent conductivity. What is conductivity first? What is conductivity?
So mathematically it's 1 upon resistivity.
Yes, but I need definition, exact definition. It is conductance produced by all the ions of an electrolyte present in unit volume. That is conductivity actually. So on dilution, what happened? Number of ions per unit volume decreases, and therefore conductivity, that is kappa, decreases. So keep in mind that conductivity, that is the conductance produced by all the ions of the electrolyte, which is present in unit volume. And on dilution, what happened? Number of ions per unit volume decreases, and therefore conductivity always decreases. But if we talk about molar conductivity, molar conductivity is conductance produced by all the ions of 1 mole of electrolyte. Present in given volume V. That's why molar conductivity is equal to conductivity divided by concentration. C mole per liter, so per mole it is K upon C. And what is C? It is 1 upon V, because V is the volume containing 1 mole of the electrolyte. So it is K into V only. So on dilution, what happened? Tell me what happened on dilution? Conductivity decreases, but volume containing 1 mole of the electrolyte, that increases. And see the size of the arrow. Decrease in conductivity is less, increase in volume is more, and that's why molar conductivity increases on dilution. So if you explain it in theoretical terms, then you can see, if we have 1 mole of electrolyte, what happened to alpha on dilution? Alpha increases on dilution. This relation, I hope, K upon C. Alpha increases on dilution, and at the same time ions are moving away from each other. So there is less electrostatic force of attraction between oppositely charged ions. So they become more free, because ions remain same, because there is 1 mole of electrolyte. So if it is weak electrolyte, ions are increasing, their electrostatic attraction is decreasing, and therefore, when we draw the diagram, this Debye-Huckel-Onsager equation, that hope you know, Debye-Huckel-Onsager equation, it is molar conductivity at given concentration is equal to molar conductivity at infinite dilution minus A under root C. So if we plot a graph between lambda MC versus under root C, graph is straight line, and if it touches the y axis, that is lambda MC axis, it gives lambda m naught. This is the molar conductivity at infinite dilution. It is for strong electrolyte. And what about weak electrolyte? For weak electrolyte, initially conductivity is less, but as it approaches 0, its conductivity increases and sometimes surpasses strong electrolyte. It is given in NCERT that it moves up. So how do it's possible? Because you see, this is NaCl. Let us say this is NaCl, and this is acetic acid. So tell me, out of H plus and Cl negative, which one has higher, H plus and Na plus, which one has higher conductivity? H plus, because of its small size, right? Now there is one more question for you. Out of Na plus and K plus, aqueous, again I mention aqueous, which one has higher conductivity, molar conductivity? Maybe? Sorry? Hello? No. K plus has somewhat higher conductivity than Na plus. Why is it so? Because Na plus, there is more hydration. Hydrated radii of Na plus is greater than hydrated radii of K plus, because they are moving in aqueous solution. So there is more hydration of Na plus than K plus. That's why K plus has higher conductivity, higher ionic movement, ionic mobility than Na plus. Lithium is still smaller, because lithium is highly hydrated because of its small size. H plus is something different, because it is very, very small in size. Even H plus ion, it is difficult to accommodate more number of H plus ions around it. That's why H plus has highest conductivity among cations. And what about anion? Which one has highest conductivity? Among cation, H plus has highest conductivity, and among anion, OH negative ion has highest conductivity. Keep in mind these two. Okay. Yes. So molar conductivity is equal to K, and K is in S per centimeter. So concentration should be in mole per centimeter cube. So to replace this concentration of mole per centimeter cube, because unit is S centimeter square per mole. So to replace it, we have to write mole per liter, then it should be multiplied by 1000, because it is 1000 centimeter cube per liter. So per liter cancel, we have per centimeter cube. So it is written simply as S per centimeter divided by molarity into 1000. So this is the formula, most common formula for molar conductivity in S centimeter square per mole. So if molar conductivity is in S meter square per mole, then conductivity should be in S per meter, concentration in mole per meter cube. So tell me now where I will put 1000. If we write it in terms of molarity, it should be here, 1000 liter per meter cube. So keep in mind, when conductivity is given in S per meter, then molarity is multiplied by 1000, and this is the case because you know that 1 liter is 1 decimeter cube, that is 1 liter is 10 raised per minus 1 meter cube, that is 10 raised per minus 3 meter cube, and 1 meter cube is 1000 liter. So it should be 1000 liter per meter cube. And to calculate this molar conductivity, we use resistance. To calculate resistance, we use this Wheatstone bridge. It is in physics as well. Wheatstone bridge is given in NCERT, this physics part.
Yes.
Okay. So this ratio, you know, null point, at null point, R1 by R2, that is equal to R3 by R4. So in this way we can calculate resistance of the unknown cell, because in one place we put cell, and on the other place we write variable resistance. So unknown resistance we can calculate by using Wheatstone bridge. Yes, Kulrosh law. So see, when I plot the graph, you know, for for strong electrolyte, this is a straight line, and therefore it touches. If we extrapolate, we can get lambda m naught. But for weak electrolyte, you know, it is like this. It can never touch the y-axis, and therefore lambda m naught for weak acid we cannot calculate by making use of Debye-Huckel-Onsager equation. So to calculate lambda m naught for weak electrolytes, we make use of Kulrosh law. What is this Kulrosh law? That whenever there is infinite dilution, what do you mean by infinite dilution? Yes, infinite dilution means when ions, oppositely charged ions will not interact with each other. Means solution is much larger, means solvent is much larger than the solute particles. Ions present in the solvent will not interact with each other, means they are independent of each other, and therefore each ion makes its own contribution towards molar conductivity. For example, if we have acetic acid, then we can take lambda m naught of H plus and lambda m naught of acetate ion and just add. So, you know, lambda m naught of HCl, H plus we can calculate from H plus from HCl, lambda m naught of acetate ion we can calculate from sodium acetate, and if we remove lambda m naught of NaCl, we can get the value of lambda m naught of acetic acid. Means by this is the application of Roche law, by making use of lambda m naught of strong electrolytes, we can calculate lambda m naught of weak electrolyte. Same, if we have to calculate lambda m naught of water, we make contribution from lambda m naught of H plus and OH negative. So again same case, H plus we can take from HCl, OH negative we can use NaOH, and if we remove NaCl from it, we can calculate lambda m naught of water. And this is lambda m naught is the maximum conductivity that can be obtained from the electrolyte. So what is alpha? That is degree of dissociation. So it is equal to lambda m C divided by lambda m naught, and same dissociation constant can be calculated from this. So by making use of Roche law, we can calculate lambda m naught of weak electrolytes, and at the same time we can calculate degree of dissociation, that is molar conductivity at given concentration divided by molar conductivity at infinite dilution. Equivalent conductivity. So in case of equivalent conductivity, you know, this is the mole conductance produced by all the ions of one equivalent of electrolyte. One equivalent of electrolyte. So lambda equivalent of NaCl is lambda Na plus, means equivalent conductivity of Na plus Cl negative. For BaCl2 we get Ba2 plus and Cl negative contribution, and if we have molar conductivity we will write it like this. Like this. Here we can use 1 by 3 lambda m of Al3 plus in this case it is 1 by 3 lambda m of Al3 plus 1 by 2 lambda m infinity of a sulfate ion. Okay, this is the question from the exam. See, a Wheatstone bridge is set up with a conductivity measurement cell as one arm of the bridge. This is the cell. Sorry. This is cell. So cell has a provision of varying separation between the electrode plates, keeping the area of the plates unchanged. So R is the resistance of the variable resistor required to achieve the balanced bridge condition. Figure 2 shows for 1 molar aqueous solution of different chloride electrolytes with different cations, all are metal chlorides. Value of R as a function of D, that is, so X, Y and Z corresponds to metal chloride with M plus. Yes. So which option is correct according to you? Of all, what we do, see there are 3 variables in this diagram, okay? In this graph, there are 3 variables, R, D and electrolyte. So let us fix one. So let us fix plate separation. So if we fix the plate separation, it is like this. Resistance of X is maximum, resistance of Y and then resistance of Z. So tell me, resistance higher means conductance less, means conductivity less. So first tell me, out of H plus, Na plus and K plus, which one has highest conductivity? H plus. If H plus conductivity is highest, that means resistance is, if conductivity is highest, so resistance is lowest. So which one has the lowest resistance? Right? So that means Z should be H plus. So now we left with 2 options, B and D. Now out of Na plus and K plus, which one has higher conductivity? K plus. That means it should be second one. So Y should be in the midway. Okay. Then it is Na plus. So that means according to me, B option should be correct.
Yes, sir, I understand where I went wrong.
Okay. So that's all about electrochemistry. Just solve questions. Okay. If you have any doubt related to question, one question, I think one student have sent me. I will take up that question. I will send the video solution of that question. Okay. And if you have any other question related to the same topic, you can send me by today evening or tomorrow morning, and I will solve them and I will send you video solutions of those questions. Okay.
Okay, sir.
Thank you, sir.
It is bit faster, but because we have to complete it in short span of time, so I have to rush through few concepts which you have already known, because these conductivity, conductance, I hope Faraday's laws, means they are well managed things. I hope I have covered. Actually, Nernst equation is most important, and effect of pH, OH negative ion, H plus, that is more important part. So that just focus on that part, because from the cell there is no question so far, as I know. And if there is any question, please do let me know.